Sustainability. It's a problem engineers have had to work around for years. According to the Food and Agriculture Organization of the UN, the number of overfished stocks globally has tripled in half a century, and today fully 1/3 of the world's assessed fisheries are currently pushed beyond their biological limits. Additionally, according to the World Resources Institute, studies have shown that fertilizers are often applied in excess of crop needs. The excess nutrients are lost through volatilization, surface runoff, and leaching to groundwater. On average, about 20% of nitrogen fertilizer is lost through surface runoff or leaching into groundwater. Whether it's fertilizer runoff or overfishing, engineers' neglect for making sustainable food processes has had irreversible effects on the health of individuals and ecosystems. It's not easy to work around, but as engineers, we have to find a way to resolve any issue we're presented with.
The developing field of aquaponics is a great example of a field dedicated to ensuring sustainability in food processes. David Blarish is a professor at Auburn University who has worked diligently in its aquaponics department over the last few years, and this is what he has to say about the topic.
What is your role in the aquaponics facility here at Auburn?
And a lot of what I would call resource recovery. So a lot of the wastes that are generated at various points. So, waste nutrients from the fish, or there's a significant amount of waste products that are generated from the fish system that we do not have a good use for without employing some other technologies to actually turn them into useful products. And so I'd say that's a major role that I have is looking for engineering solutions that we can apply towards closing the loops and using more of the resources within the system.
How much food, or if any, does the aquaponics facility provide for those in Auburn?
So overall, we're looking at a couple 100 pounds a week of food product that's coming from the system in sort of average levels of operation.
Why would you say it's important for engineers to keep sustainability in mind while designing different food systems and different processes?
That's like the money element. The farmer who's raising fish is buying nitrogen in the form of protein feed. And they feed it to their fish, and then the fish just excrete it. And so that's 70% of every dollar that's just going into wastewater. And so that's the whole argument for trying aquaponics in the first place, is because the nitrogen and then some of the other elements, phosphorus and iron and potassium, are coming out of the fish. They're already dissolved in the water in a form that plants really like to take up. So that's always been the motivation, is like, well, trying to recover some of those waste nutrients by growing crops off of them.
So how does the aquaponics facility deal with the waste and the byproducts to make the process more sustainable and, as you said, close that loop?
Materials efficiency is sustainability. And the only way to get to sustainability is to be able to close a bunch of loops as much as possible, materials loops and resource use.
Gotcha.
That's the questions that we're asking about the whole aquaponics system, is like, how efficient is it? How sustainable is it from, the three pillars of sustainability, from, environmental sustainability, the resources it uses, the economic sustainability, does it make money, or does it at least provide for itself? And then also there's other questions we don't ask as much about, but we could, about the social sustainability. Are people happy using it?
Just as Professor Blarish explained, we have to close as many waste loops in our food processes as possible to ensure sustainability in three key areas: environmental, economic, and social. As seen in the example of aquaponics, all three of these can be met if you're creative enough with how you solve the problem.
Sustainable agriculture engineering practices are important to everyone, as we all need clean water to drink, nutritious food for energy, and a pollution-free environment to live in. If we keep these things in mind whenever we design whatever we work on as engineers, we can make the world a better place for our own health and the health of future generations.